let's go ahead and verify the following trig identity. So we'll do this by simplifying both hand sides of the identity. First, we'll rewrite each side in terms of sine and cosine. So the left-hand side can be rewritten as 1 over cosine raised to the fourth x minus sine x divided by cosine x. All of this is raised to the fourth. And the right-hand side is going to be equal to 1 over cosine squared x plus our sine x divided by cosine x raised to the second. Again, this route doesn't look promising, so we should probably look at another way of solving this problem. It's possible that you could solve the problem using this way, but it wouldn't be the easiest. So let's go ahead and look at the left-hand side a little closer. Here again we have our secant raised to the fourth x minus tan raised to the fourth x. And the thing that we can notice is that this is going to be equal to a perfect square. In other words, if we replace our secant x raised to the second with an x squared, and replace our tan raised to the fourth x with a y squared, we can rewrite this as x minus y times x plus y. That means the secant for x minus tan raised to the fourth x can be rewritten as secant squared x minus tan squared x times secant squared x plus tan squared x. Now, go ahead and recall that tan squared x plus 1 is equal to a secant squared x. That means secant squared x minus tan squared x is equal to 1. So we can replace this term with just 1, and we get that this is going to be 1 times secant squared x plus tan squared x. And we're done, because we've shown the left-hand side is equal to the right-hand side. We're going to finish off this section by looking at a technique called trigonometric substitution. This allows us to convert algebraic expressions into trig ones. This is going to be useful in calculus, especially in Calc 3, when you're looking at surface integrals and vector-valued functions. Let's make the indicated substitution for the function 1 divided by x squared times the square root of 4 plus x squared, where we replace our x value with 2 tan theta, and our theta values are between 0 and pi divided by 2. First, let's go ahead and rewrite our expression, which is 1 divided by x squared times the square root of 4 plus x squared. Now, replace each x with 2 tan theta. This is equivalent to 1 divided by 4 tan squared theta times the square root of 4 plus 4 tan squared theta. Withdrawing the 4 out of this term, this is equal to 1 divided by 4 tan squared theta times the square root of 4 times 1 plus tan squared theta. We can pull the 4 out, and this simplifies to be 1 divided by 8 tan squared theta, and we can replace our 1 plus tan squared theta with our secant squared theta. So this is going to be secant squared theta. And again, this is because 1 plus tan squared theta is equal to a secant squared theta. Simplifying this further, we'll get 1 divided by 8 tan squared theta times secant theta. Now finally, if we want, we can rewrite our tan squared theta as a cotan squared theta and our secant theta as a cosine theta. Then this is going to be equal to 1 divided by 8 cotan squared theta times cosecant theta. And we're done.